All right, let's get right into this. We are about to unpack a genuine cosmic detective story. Seriously, it's all about an object from way outside our solar system that's, well, not behaving the way it's supposed to. And it's making us ask some pretty huge questions.
And yeah, that's really the heart of the whole mystery, right there on the screen. Our story kicks off with something that astronomers tagged as a comet, but its behavior, it's just off. It's suggesting it might be something else entirely, something that could literally change everything we think we know.
Okay, so let's start at the scene of the crime. The whole problem centers on this object. Its official name is 3I/Atlas, and it is veering off its predicted path as it flies through our solar system.
This was the exact moment the alarm bells went off. Scientists were tracking 3I/Atlas, and when the data came back, it was just clear. This thing was not where all of our calculations about gravity said it should be.
Now, I know what you're thinking. 4 arcseconds. That doesn't sound like a lot, right? But to put it in perspective, that's kind of like aiming a laser pointer at a specific window on a skyscraper and hitting a building 2 blocks away instead. In space terms, it's a gigantic miss. And it means some other mysterious force, something besides the sun's gravity, is giving this thing an extra push. This is where the real investigation begins.
So, this effect has a name. It's called non-gravitational acceleration. And this is the key concept we need to understand. It's the smoking gun, really. It's the hard evidence that something is actively pushing 3I/Atlas. The billion-dollar question is, what's doing the pushing?
Okay, so the first and most obvious suspect is just normal comet stuff. As a comet gets close to the sun, all the ice on its surface heats up, turns into gas, and shoots out into space like thousands of tiny rocket thrusters. This is called outgassing. So could that explain this mysterious push?
Well, here's where it gets really interesting. Harvard astronomer Avi Loeb actually did the math. He looked at how strong that mysterious push was, and then he calculated how much rocket fuel, how much gas and dust the comet would have to be blasting out to create that push. And the answer is just staggering. To speed up that much, 3I/Atlas would have had to blast off at least 1/6 of its entire body weight in about a month.
And this number really shows you the problem with the comet theory, that 1/6 of its mass works out to a gas cloud weighing at least 5.5 billion tons. So if the natural explanation is right, that massive cloud of gas has to be there. It's not optional. We should be able to see it, plain as day. Now, what's so wild about all this is that it feels strangely familiar. This isn't actually the first interstellar visitor to act this weirdly. It has a predecessor, a very famous one, that sparked a nearly identical debate just a few years ago.
Remember Oumuamua? Of course you do. It was the very first object we ever saw that came from another star system. And guess what? It also had a mysterious push with no visible tail. Now, to try and explain it, some scientists came up with this idea of a dark comet, maybe a chunk of solid hydrogen that's evaporating in a way that's totally invisible to our telescopes, but still creating that push. It's a really interesting idea, but it's totally unproven.
So, this leaves us with two main suspects in our little cosmic mystery. On one side, you've got Hypothesis A. 3I/Atlas is a natural dark comet, a totally new kind of object that we've just never seen before. And on the other side, you've got Hypothesis B. The push isn't natural at all. It's a technological signature. It's coming from some kind of propulsion system.
Avi Loeb uses this incredible analogy to frame the whole debate. He's basically saying that trying to force this weird object into the comet box, even though the data doesn't quite fit, could be a massive failure of imagination. Are we just looking at a rare rock, or are we missing the bigger picture entirely because we're stuck using old labels?
But here's the best part. This isn't just going to be some endless debate. Unlike with Oumuamua, which flew by so fast we barely got a look at it, we actually have a chance to solve this mystery with 3I/Atlas. We have a clear, simple test we can run. And here's the schedule for this cosmic showdown. There's a massive international observation campaign planned, and it all comes down to one really key date, December 19th, 2025. On that day, 3I/Atlas makes its closest pass by Earth, and you better believe every major telescope we have, from the Webb and Hubble in space to hundreds on the ground, will be pointed right at it.
So what are they all looking for? It all boils down to this one simple question. If the telescopes see a 5.5 billion-ton cloud of gas surrounding the object, then hey, the comet theory wins. It's just a weird natural thing. But if they look and they find nothing, then the mystery gets a whole lot deeper.
You know, when you step back, this whole episode is about way more than just one object flying through space. It's a live, real-time example of a really fundamental debate about how we actually do science and how we confront things we don't understand.
The central argument here is that we have to let the evidence lead us, wherever it goes. When the data doesn't fit our existing theories, we shouldn't just try to ignore the data or explain it away. Maybe we should start questioning our theories.
And this quote just sums it all up perfectly. It doesn't matter what the most popular opinion is, or what we expect to find, or what we want to find. The only thing that matters is what those telescopes are going to show us. The data gets the final say, period.
So as we get closer to this moment of truth, that's the real question on the table. And what's so cool is that both possibilities are absolutely fascinating. Either we are about to discover a brand new type of object in our universe, a dark comet, or we could be on the verge of finding the very first evidence of technology from beyond our solar system. All we can do now is wait and watch the data.